Day 1. I thought it was day 2. I forgot about day 0. It's really day 1. Day 1 notes. Here we go. Special reference triangles. They're special. And I'm going to reference them. And here we go. Here we go. Oh my gosh, I'm so excited. All right, let's talk about 2 special right triangles. And these are kind of a big deal. These are some things you should just kind of commit to the brain. All right, so let's talk about an isosceles right triangle. First of all, isosceles right triangle means that these 2 sides are equal. Those are the legs of my right triangle. This is my hypotenuse. So, of course, and if this is 90 and these 2 sides are equal, then aren't these 2 angles then going to be both 45 degrees? Now that 4 is perfect, and that 4 looks like a 9. They're 45 degrees. So let's say we call our hypotenuse 2. And I want to figure out what the lengths of these sides are. Not really sure how I'm going to do it. Let's figure it out. Oh, we'll call them x. And I'm going to guess it has something to do with the Pythagorean theorem, like, x squared plus x squared equals 2 squared. Okay? Well, x squared plus x squared is really 2x squared is equal to 4. Divide both sides by 2, and I get x squared is equal to 2. I take the square root of both sides. Now, normally I'd put plus or minus the square root of 2, but because it's lengths, we're really just going to use the positive square root, so square root of 2. So that means that x is equal to the square root of 2. Let's come back to that. Let's do this other triangle. Now, this is an equilateral triangle. Ka-ching, ka-ching, and that whole side, this whole side, ka-ching, right? And then this is half a ka-ching. Well, let's say the sides of this triangle are all 2. Well, then that would make this 1. Then, and I apologize, this doesn't quite look like an isosceles triangle. You just kind of got to use your brain and get used to that. Because every triangle you draw is not going to be perfectly accurate as well. You just have to remember the ratios of these sides. Okay, so something else I remember is that in an isosceles, in an equilateral triangle, all angles are 60 degrees. So this angle would be 60. Therefore, this angle would be 30 degrees. So this is what's called a 30, 60, 90 right triangle. And I apologize. This one is a 45, 45, 90 right triangle. Those are degrees, obviously, not radians. So let's see if I can find out, because the only thing I don't know on this one is, now I don't know this, which is x, which is this height of this triangle. So let's see if I can figure that out. X squared plus 1 squared equals 2 squared. Or x squared plus 1 equals 4. Or x squared equals 3. Or obviously x is equal to the square root of 3. Now, one of the things I want to make sure you understand is we've only worked with this right triangle. Let's say we're not using this triangle on the right, not this right triangle. We're really only dealing with this triangle, which is a 30, 60, 90 right triangle. Okay. So what I want to do is I want to know the exact values. Now, exact doesn't mean we throw it in our calculator and we write down 38 decimals or whatever your calculator will come out to be. Exact means exact. It's exactly what it means. It means exact. So, if I want to talk about 30-degree angles, then I want to work in the 30, 60, 90 right triangle. If I want to talk about 45, I'm going to work in the 45-degree triangle. And if I want to talk about 60-degree angles, I'm going to work back in this 45-degree angle. So let's see what we got here. So I'm going to reinvent this 30, 60, 90 right triangle that I drew up there. 1, 2, square root of 3. That's what we came up with, right? And this was 60. And this one was 30. And it should make sense that opposite the smallest angle is the smallest side. Square root of 3 is 1.7 something. So what is sine? Well, sine is opposite over hypotenuse. What is cosine? Adjacent over hypotenuse. And what is tangent? Opposite over adjacent. So let's go. Well, before I can do that, maybe I should label this thing. Hypotenuse. Now we're talking about the 30-degree angle. That's up here. So that makes this opposite and this adjacent. And that's only because we're not talking about this 60-degree angle. We're talking about this 30, and opposite this 30 is the opposite side. So opposite over hypotenuse, 1/2. So the sine of 30 degrees is 1/2. What's the cosine of 30 degrees? Well, the cosine of 30 degrees is adjacent over hypotenuse, or the square root of 3 over 2. And what is the tangent? Well, the tangent is opposite over hypotenuse, or opposite over adjacent, which is 1 over the square root of 3. But we can't leave it like that. We have to rationalize it. And we've done this a couple of times. It's really times the square root of 3 over the square root of 3. So this is really equal to the square root of 3 over 3. Okay. Well, remember, these are just our reciprocal functions. So secant goes with, don't forget sine, it's the reciprocal of sine, so that would be 2 over 1, or just 2. Now, this one's a little bit trickier. We've got to take the reciprocal of this, which is 2 over the square root of 3. So we have to multiply by the square root of 3 over the square root of 3, which is 2 square roots of 3 over 3. And cotangent is just the reciprocal of tangent, but let's use this one, not its converted form, because if I take the reciprocal of that, I just get the square root of 3. All right, let's do 45. Now, in a 45, 45, 90 triangle, let me put it back up here small. These sides are the same, and this is 2. So this is the square root of 2. This is the square root of 2. So the sine of 45 is, well, it doesn't really matter which one I call the angle. Let's call this one my angle. And this would be my opposite. This would be my hypotenuse, and this would be my adjacent. So sine of 45 is opposite over hypotenuse, square root of 2 over 2. Cosine is opposite, or is adjacent over hypotenuse, but it's also the square root of 2 over 2, which should come as no surprise. Tangent is equal to opposite over adjacent, which is the square root of 2 over the square root of 2, but that's just 1. Now, we got to do all the reciprocals. So reciprocal of sine would be 2 over radical 2, but in order to do that, we got to multiply by radical 2 over radical 2, which is 2 radical 2 over 2, but the 2's cancel, so it's really just radical 2. Okay. Well, if that's true, then secant's also going to be radical 2. And cotangent's just the reciprocal of tangent, which is just 1, so it's also 1. And finally, let's do this sine function. Let's do it like this. I'm going to make a big triangle for sine. So now we'll do the 60-degree angle down here. 60 degrees. This would be my 90. So this is my hypotenuse. This is my opposite. Opposite. And this would be my adjacent this time. And if you remember correctly, the hypotenuse is 2. This little sign down here is 1. And this is the square root of 3. So sine is opposite over hypotenuse. The square root of 3 over 2. Cosine is adjacent over hypotenuse. 1 over 2. Tangent is opposite over adjacent. Square root of 3 over 1, which is just the square root of 3. All right, now we got to do all the reciprocals. Now, what is the reciprocal of 2 over radical 3? Well, we already did that before, and we got 2 radical 3 over 3. We did that over here. Secant is just the reciprocal of cosine, so that's just 2. And this is the reciprocal of that, which is 1 over radical 3, but we did that before. We found out that's radical 3 over 3. All right. Oh, sorry. I just rewatched what I did. I almost fell asleep. What? Yeah, I apologize for that. It was kind of boring. I'm not going to lie. That was kind of boring, but it's necessary. Yeah, not all math is fun and glitz and glamour. I know you're used to the fun and glitz and glamour, but that's what they make coffee for. All right, I'm awake now. Got my nap in. All right. So let me tell you why we did this. All right, so any 45, 45, 90 or 30, 60, 90 triangle is just a dilation of one of those triangles, which means, of course, if they're dilations of each other, that means they're similar. Well, why is that important? Well, if they are similar, their angles are congruent. Let me start using some symbols so I can stop writing so much. Are congruent. Well, why is that important? Well, that's important because their sides are proportional. Proportional. So in order to solve it, all we really need to do is set up a proportion. Solve what? Oh, let's see what we got. Let's say I talk about this. And let's say my problem really is this. I want to find x. Well, I'm used to a 30, 60, 90. Clearly, this is 60 down here. I'm used to a 30, 60, 90 triangle that is the hypotenuse is 2. Opposite the 30-degree angle is the small side. Opposite the 60-degree angle is the middle side. I'm used to the 2, 1, and square root of 3 triangle. But that's not what I was given. I was given one where they have a hypotenuse of 8. Well, if I remember that all 30, 60, 90 triangles are similar, because their angles are all the same, I then can just say, okay, all I got to do is set up a proportion to find any given side. So if I wanted to find x here, I could say, okay, x, it'll take a little hiccup on my computer, sorry, x over 8, so this side over the hypotenuse is equal to this side, square root of 3, over the hypotenuse 2. Okay, so I get 8 square roots of 3 is equal to 2x. Divide both sides by 2. And I get x is equal to 4 square roots of 3. Oh, 4 square roots of 3. Well, that was pretty easy. What if I wanted to find y? What if there was a y down here? I'd say, okay, y over 8. So the side opposite the 30 over 8 is equal to the side opposite the 30, which is 1 over 2. Cross multiply, I get 2y equals 8, so y just equals 4. Oh, 4. And it doesn't matter what size I make this large triangle. Whatever size this triangle is, I just have to remember that it is going to be proportional to any 30, 60, 90 triangle, which is always 2 square roots of 3, 1. Well, I can do the same thing with 45, 45, 90 right triangles. Let's say I wanted to solve these, x. These are both x. So those are both going to be those values right there. So I'll set up that same proportion. X over 5, or my side length to my hypotenuse, is equal to my side length to my hypotenuse, the square root of 2 over 2. All right, so 2x equals 5 square roots of 2, divide by 2, divide by 2, and I get x equals 5 square roots of 2 over 2. Well, of course, this one's also the same length. All right, let's see if we can figure out how that's going to become out. Oh, all right, so let's see what we got here. Find the exact value of these. Now, at this point, you probably haven't memorized the triangles. So what I want to do very quickly on these is just sketch a 45, 45, 90 right triangle. Really quick. And I remember a 45, 45, 45, I can't speak English. 45, 45, 90 is 2, and these are going to be the square roots of 2. Oh, okay. And let's call this my angle down here, my 45. All right. Well, sine is opposite over hypotenuse, so that would be the square root of 2 over 2. Tangent is opposite over adjacent, which is the square root of 2 over the square root of 2. But wait a second. That's much easier just to remember. That's 1. Oh, well, then this is just equal to the square root of 2 over 2. Well, okay. Secant 45 makes me nervous. I don't understand secant 45. So I'm going to try to remember that that's the reciprocal of cosine of 45 degrees. Okay? If you can try to remember C and S go together, and we hate all math students in New York State and every place else that they learn trig, you can remember that those don't go together. So let's go back to that same 45, 45, 90. Square root of 2, 2, square root of 2. The legs are square root of 2, and the hypotenuse is 2. Ooh, sorry about that. I covered up. Yes, Miss New. I'll go wash my hands now. One of my pain in the neck students loves for me to tell me to wash my hands after I cough. Yeah, whatever, kid. I will, though. Cotangent is opposite over adjacent. Oh, wait, maybe we should hypotenuse, opposite, adjacent. Again, this is going to be our angle down here again. Oh, I never labeled this one over here. O, H, and A. Sorry about that. So cotangent is A over O. O over A. It doesn't matter. It's the flip of this one. And I know this one's 1, so this one's 1. So the secant 45, that's not as easy. It's not as easy. So I'm going to remember some old horse caught another horse. So cosine is another horse. So that means secant is horse another, or hypotenuse over adjacent. So that would be 2 over radical 2. So 2 over radical 2 times 1 is 2 over radical 2. But you can't leave it like that, kids. You got to multiply by radical 2 over radical 2. Remember, we're multiplying by just 1 here. So that means that gives me 2 radical. That looks terrible. 2 radical 2 over, and if I multiply these two together, I get 2, and then these cancel. So my final answer here is just radical 2. All right, let's do this one. Okay, now we got some subtraction. So we already did we do cosine of 45 yet? No. So again, let's look at that triangle. Doesn't hurt to draw this. Takes 2 seconds. 45. 2, radical 2, radical 2. And cosine is, let's see, hypotenuse, opposite, adjacent. Cosine is caught another horse. So when I talk about cosine of 45, it's the square root of 2 over 2, adjacent over hypotenuse. So 4 times the square root of 2 over 2 minus 2 times, now sine is opposite over hypotenuse, so that's also equal to the square root of 2 over 2. Now let me go back up here and show you something. Do you see this word exact value? Okay, if you give me a decimal and I ask you for an exact value, we are going to have some serious major problems. Do not grab your calculator and say, Mr. Krause, I went out 17 decimals. The calculator gave me 17 decimals. That's exact. You can't get any more exact than that. Yes, you can. That is not correct. These are irrational numbers, which means your calculator will always just give you an approximation. You have to have the exact value. All right, so the math here is not bad. 2 goes into 4 twice, so this gives me 2 square roots of 2. These 2's just cancel, so that's minus the square root of 2. So my answer again is just, oh, look at that, square root of 2. Nice. All right, so I just did the sine of 45. That's the square root of 2 over 2. But now I've got the cosine of 30. So I actually like to draw this triangle. This is my favorite one to draw. The 30, and then the 60, and then the 90. 30, 60, 90, where this is 2. The side opposite the small side is always the 1, and then the square root of 3 is opposite to 60. So, cosine of 30. Let's label it. Hypotenuse, opposite, and adjacent. Now, cosine is caught another horse. It's adjacent over hypotenuse. Square root of 3 over 2. All right. Now, if you multiply fractions, you multiply numerators, multiply denominators. Square root of 6 over 4. Do not reduce it. Notice this one is in a radical. This one is not. They cannot be reduced. That's it. Problem's over with. Stop. All right, so these are a little odd. These are a little odd. This is the nomenclature for squaring a trig function. Sorry about that. For squaring a trig function. So I want to blow this up. I want to, oh man, what the heck? I want to make, am I still on this page? I hope. Good. I just want to make this bigger. All right, so I want you to really focus in on this. This is what you're going to see. You'll either see something like this, tangent or tangent squared of theta, or tangent squared of x, or something like that, where you'll see that the word tangent has the square on it. I want you to understand what this actually means. What this actually means is the tangent of 30, that whole thing squared. This one would be the sine of 45 squared. So while the nomenclature, or the way we look and represent it mathematically, is the square on the word tan, what they really are doing is taking the tangent of 30 and squaring that. So you need to get comfortable with that. All right, so now that we've gone through that, let's take a look at our 30, 60, 90 right triangle. We'll try to draw a 30, 60, 90 right triangle. I think I failed with my 90. Okay, we'll pretend like that's 90. So 30, opposite of 30 is 1. And then our lone one is the square root of 3. All right, so let's see what we got. Yes, this is a 90-degree angle. So tangent, taking oats away. Well, the first thing I probably ought to do is label this thing hypotenuse, opposite. Because now why is it opposite? Because opposite the 30 is that one. And adjacent. So taking oats away. Oats away. So this would be 1 over the square root of 3 squared. Sine of 45 we just did a few minutes ago. Hopefully by now you've sort of memorized that that's square root of 2 over 2, and we will square that as well. So what is 1 over the square root of 3 times 1 over the square root of 3? In other words, you're going to square the numerator, square the denominator. You just get 1/3. If I square the numerator here, I get 2. If I square the denominator, I get 4. So now I multiply those together, and I get 2 over 12, or 1 over 6. All right, let's move on. Tangent of 45 we just did a few minutes ago. That was 1. Now sine of 60, I haven't looked at a 60-degree angle yet, so let me draw this again real quick. It doesn't take long. 2 opposite the 30 is the 1. Opposite that 60 is the square root of 3. Now, we're talking about a 60-degree angle. So this is now my angle. This is still my hypotenuse, but opposite the 60-degree angle is this, opposite. Opposite, and then whatever's left over is my adjacent. So sine is opposite some old horse, right? Opposite over hypotenuse minus the square root of 3 over 2. So opposite over hypotenuse. Well, you know what this is equal to? I don't know. Let's combine it. So really, this is really 2 over 2 minus the square root of 3 over 2. So keep the denominator 2, and you get 2 minus the square root of 3 over 2. You could have probably left it as 1 minus the square root of 3 over 2, but if they said write it as one fraction, we probably should have, then that's what you would have had to do. That's it, kids. That's all she wrote. I'm done. Yay!